Hello everyone and welcome to Geometry Section 2.5, If-Then Statements and Deductive Reasoning. In this section we'll get an introduction to the basic pieces that make up logical statements and proofs. Yep, that was the P word. Proofs are a way of justifying the steps we've taken to solve a problem. It's like providing evidence that the answer you got is the right one and that the steps you took to get there are mathematically legal. So let's start with some terminology. If-then statements make up the majority of all the statements that we'll see. These are conjectures formed from combining a hypothesis and a conclusion. The hypothesis of an if-then statement is the part that starts with if. The hypothesis tells us what information is necessary in order for the statement to be true. The conclusion is the part of the if-then statement that begins with then. This tells us the rule that can be applied if the hypothesis is true. Remember in Chapter 1 we talked about two types of reasoning, inductive and deductive. In inductive reasoning, we're making predictions based on patterns. Deductive reasoning is much more formal but also much more accurate. Deductive reasoning uses facts, definitions, properties, and laws of logic to make logical arguments. Let's look at an example of an if-then statement. If you do your best on your homework, then your test scores will be higher. In this statement, the part beginning with if you do your best on your homework is the hypothesis. The second part beginning with then your test scores will be higher is the conclusion. Let's say we've accepted that this is a true statement. Then, if you do your best on your homework, you can expect your test scores to be higher. Let's see if you can pick out the hypothesis and conclusion for each of these statements. In our first example, if I sleep through my alarm, then I will miss the bus. Our hypothesis starts with if, so that would be I sleep through my alarm. The conclusion is what's left after then. I will miss the bus. Next example, if an animal is a mammal, then it has hair. So our hypothesis is an animal is a mammal, and we're concluding with it has hair. Finally, if an angle is acute, then it measures between 0 and 90 degrees. Here the hypothesis after the if is an angle is acute, and the conclusion after the then is it measures between 0 and 90 degrees. Now let's see if you can make some if-then statements. Remember, you're looking for a hypothesis and a conclusion. Every duck on the pond is hungry. Our hypothesis here is a duck on the pond, and the conclusion is that it's hungry. So if you put these two together, we get if a duck is on the pond, then it is hungry. In our next example, we have every right angle measures 90 degrees. So take the statement apart. Start with a right angle and end with it measures 90 degrees. Then we have, if an angle is a right angle, then it measures 90 degrees. Finally, I will get good grades if I work hard. Hopefully you picked up on your keyword if in this statement. It's really just backwards. If I work hard, then I will get good grades. Earlier when we defined deductive reasoning, I mentioned laws of logic. There are two laws that we use when working with if-then statements. The first is the law of detachment. The law of detachment tells us that if the hypothesis of an if-then statement is true, then the conclusion is also true. Let's go back to our statement, if an animal is a mammal, then it has hair. If we use this statement in consideration of an animal we know is a mammal, maybe a dolphin, then a dolphin must have hair, despite their seemingly baby-soft skin. The second law is the law of syllogism. The law of syllogism works like this. Let's say we have two if-then statements. If you do your homework, then you'll pass your tests. And if you pass your tests, then you'll pass the class. The law of syllogism says that when the conclusion of one true statement matches the hypothesis of a second true statement, we can combine the two to make one true statement. In our example, the conclusion of the first statement, you will pass your tests, matches the hypothesis of the second statement, you pass your tests. Then we can combine the hypothesis of the first statement, if you do your homework, with the conclusion of the second statement, then you'll pass the class. This results in the statement, if you do your homework, then you'll pass the class. Next, let's look at a few problems that will help us apply these laws of logic. First, we'll practice using the law of detachment to make a conclusion from a pair of statements. In our first pair, we have the statements, if you are late for your interview, you probably will not be offered the job, and you are late for your interview. Since the second statement, you are late for your interview, matches the hypothesis of the if-then statement, the law of detachment tells us that the conclusion must be true. So our conclusion is that you will probably not be offered the job. In the next example, we have the statements, if two lines are parallel, then they never meet, and two lines never meet. This time, our second statement matches the conclusion of the first statement. In this case, we can't conclude anything. Make sure you understand that in the law of detachment, you have to know that the hypothesis is true. Once you know that, you know the conclusion will also be true. In our next example, we have, if an angle measures 120 degrees, then it is obtuse, and an angle is obtuse. Since our second statement matches our conclusion and not our hypothesis, we're again left with no conclusion. Finally, we have the statements, if an animal is a carnivore, then it eats meat, and an eagle is a carnivore. This time, our second statement matches the hypothesis of the first, so we can conclude that, since an eagle is a carnivore, it eats meat. Now let's practice using the law of syllogism. We're going to combine two if-then statements into one and then try to draw a conclusion. Let's look at our first set. If Naomi saves enough money, she can buy a concert ticket. If she buys a concert ticket, she can see her favorite band. Naomi saved enough money. The conclusion of the first statement matches the hypothesis of the second statement. So using the law of syllogism, these two statements can be put together to read, if Naomi saves enough money, she can see her favorite band. Now, a little more practice with that law of detachment. We're told that Naomi saved enough money, so we can conclude that she can see her favorite band. Our final example for this lesson gives us these statements. If the rain becomes sleet, then the roads will ice over. If the roads ice over, then school will be delayed. The rain turned to sleet. The hypothesis of the first if-then statement is the rain becomes sleet, and the conclusion of that statement is the roads will ice over. The hypothesis of the second statement is the roads ice over, and the conclusion is school will be delayed. Since the conclusion of the first statement matches the hypothesis of the second statement, we can put them together to make one statement. If the rain becomes sleet, then school will be delayed. Then we're told that the rain did turn to sleet, so we can conclude that school will be delayed. That's it for the basics of deductive reasoning and basic laws of logic. Please work hard at learning these concepts. We'll be using if-then statements and deductive reasoning throughout the course, so it's important for you to master these concepts as soon as possible. Remember, you can always rewatch parts of the video if there was anything you didn't understand. Thanks for joining me, and happy hypothesizing.